In July 2026, walls of flame forced over 300,000 people to evacuate their homes across France and Spain as massive wildfires pushed toward major population centers. But the burning extended far beyond the hot, dry Mediterranean. In the Scottish Highlands, a landscape famous for its damp, rugged, and freezing conditions, a cataclysmic inferno tore through ancient forests for 12 straight days. Emergency responders across the continent are encountering a threat that renders traditional firefighting tactics useless. Authorities classify these as sixth-generation fires. They burn intensely hot, they behave unpredictably, and spread with a speed that quickly overwhelms local suppression efforts. These blazes burn with so much energy they create their own weather systems. They generate pyrocumulonimbus clouds, towering thunderstorms birthed from the intense heat. These clouds produce powerful updrafts, erratic winds, and hurl lightning strikes miles away to ignite entirely new blazes ahead of the main front. Traditional containment strategies fail once a fire begins interacting with the upper atmosphere. These systems generate their own lightning and erratic wind patterns, which can ignite multiple new fronts simultaneously and render a single line of defense ineffective. To understand why Europe is suddenly so flammable, we have to look thousands of miles north. The mechanics driving these megafires begin with the rapidly warming waters and disappearing sea ice of the Arctic. This map shows the jet stream, the high-altitude band of wind that heavily directs Earth's weather. It is powered by the sharp temperature difference between the freezing poles and the warm equator, acting as an engine that continuously pushes weather systems across Europe. But the Arctic is warming 4 times faster than the rest of the planet. As the temperature gap between the North Pole and the equator shrinks, the engine loses power. The jet stream becomes sluggish and wavy, leaving weather patterns stalled over continents for weeks instead of pushing them along. When one of these meandering waves parks itself over Europe, it traps a high-pressure heat dome directly over the landmass, relentlessly baking the region day after day. The loss of polar ice has crippled the atmospheric machinery that used to keep Europe temperate. The continent is essentially being preheated, turning dense forests and moorlands into highly combustible kindling long before the first spark is struck. After weeks sitting under a heat dome, evaporation kicks into overdrive. The sustained high temperatures suck the moisture out of the soil and the vegetation, leaving these landscapes critically dry. Under these conditions, an ignition source as small as an abandoned campfire or a discarded cigarette drops into a perfect tinderbox, allowing the flames to bypass normal early containment. A fire the size of a tennis court can expand into an unstoppable wall of flame in just a few hours. In a matter of days, single fires consume tens of thousands of hectares. What remains is a blackened landscape and a horizon of thick smoke. This highlights a significant logistical mismatch. Local fire departments are facing an atmospheric feedback loop, using equipment and budgets meant for small, manageable brush fires. During the Cairngorms wildfire in Scotland, local infrastructure reached its physical limits. Without a dedicated public fleet of specialized aircraft, emergency services had to rely on a patchwork of private helicopters to drop water on the blaze. This exposes a harsh logistical reality. No single nation possesses the resources to fight a sixth-generation megafire completely on its own. The European Union recognized this shortfall and activated the Civil Protection Mechanism, mobilizing a shared, continent-wide strategic reserve known as the Rescue Fleet. When the 2026 fires peaked in France and Spain, those nations received an immediate injection of firefighting aircraft, helicopters, and ground personnel from 7 different European countries. Coordinating a response of this magnitude requires a centralized nerve center. Operations are managed across borders in real time, utilizing satellite mapping to track fire fronts and intelligently direct multinational resources exactly where they are needed most. The fallout demands this level of integration. This diagram illustrates how the toxic PM 2.5 smoke generated by these fires ignores national borders, spreading hundreds of miles and creating severe air quality and health crises in neighboring countries, untouched by the actual flames. Europe is adapting to an escalating baseline of disaster. Surviving it demands an integrated, borderless defense on the ground, even as the true battle is being lost in the melting ice of the Arctic.